Okay, in this video I'll do a problem which is number 3 here. Maybe I'll get to number 4 in this video. These are problems for subnetting of IPv4 addresses. And here we're starting with a Class C private network, 192.168.1. And this is a /24 because it's a Class C. And we're going to break this up into /26 subnets. And there's two things you can do with this 26. You can say it's 2 more than 24, meaning the number of subnet bits is 2. You can also say 32 minus 26 is 6, meaning the number of host bits is 6. One way or the other, the number of subnet bits plus the number of host bits is 8, because we're starting with a /24. And so what I do when I look at this problem is I make a picture of my IP address and think of this in terms of bits. And if I start with a /24, I'm going to put my line here and say n is equal to 24. I got 8, 8, and 8 bits. I got the first 3 octets are the network address, 192.168.1. Those are fixed. And I've got this last octet to work with for subnets and hosts. And since it's a /26, I've got 2 for the subnets and 6 for the hosts. So S is 2, H is 6, and I've got 4 subnets, and 2 to the 6th is 64 IP addresses in each. And so this 64 is our increment in this case in the 4th octet of our IP address. Okay. There's a general rule you can follow, which is that the increment in the octet is always equal to the rightmost S-bit place value in the binary representation. So the leftmost bit in this octet is the 128s. The next one over is the 64's place. So we have the 128's place and the 64's place. And it's the rightmost S-bit is in the 64's place, and that gives us this 64 as well. In any case, we're going to increment by 64's in the rightmost octet, and those are going to give us our 4 subnet IDs, and that works out well because we're supposed to have 4 subnets. The next number in the sequence would be 256, which of course we can't have because our values in this octet are 0 to 255. And so I added 1 to get the first IP for the host. On the broadcast IP, I subtracted 1 from the previous subnet ID from 64 to 63. Subtract 1 more for the last host IP. Okay. I will go to the next problem here. Here we're going to take the same. We're going to take a slightly different 192.168.2 Class C, and we're going to break it into /27s. The picture for this that I draw is very similar. 4 octets, starting with an n equals 24 with 8, 8, and 8 bits. And now with a /27, 32 minus 27 is 5. So I have 5 host bits. I can also look 24 plus 3 is giving me 3 S-bits. So I'm going to have 8 subnets. 2 to the 5th is 32 IP addresses each. 32 is my increment as I draw out the subnet IDs. One more value of 32. 224 plus 32 is 256, which rolls us around. So we have 8 subnets. Here's their subnet IDs. First IP addresses, add 1 to those IP addresses. The broadcasts are subtracted 1 from the next subnet ID, and the last host IP subtracts 1 from the broadcast. Okay. Again, we can follow the rule that the rightmost S-bit, the placeholder of it in the binary, is the increment. Okay. So the increment here is 32. The 3 placeholders here are 128, 64, and 32. So the third one over, the rightmost S-bit, gives us the increment. Okay, so I hope that helps on these 2 problems. I definitely recommend drawing this little picture that I've got here to help you keep all of this straight as you go to draw your subnet IDs. Hope that helps.